talked about IP version 4 address, and I don't have you guys gone through those videos again? You need to go through those videos again. It will really be helpful for you guys. Toby, you requested for me to help you upload that video on the YouTube that it's easier for you to watch on YouTube. You were not saying anything about it again. What happened now?
No. So I just if you've I was I'm not sure. Should I
Are you still comfortable with the one I'm sending to the group? You said your storage is full on your phone. You don't want to engage, you don't want to fill it up again or something like that.
yes, but I'm using my laptop for now. But
Oh,
if you've uploaded it on YouTube, it will
no,
be
I've
easy for
not.
me.
I've not. If
Okay.
you want it, I can be doing that for you. And others
Yes.
also, if they want to access it from there, fine. You know, for us in this part of the world, we like to manage data because we don't have access to cheap data or cheap internet connection like you people.
Okay.
So yes, so but for you, I can be putting it on, but you need to keep on reminding me if you don't see it.
Okay, no problem, sir.
Yeah.
The YouTube channel and everything. You'll send it
Yeah, I
to
will
me.
send everything to the platform in case other
Okay,
people
sir.
too want to watch from there.
All right, sir.
All right. So this is to continue from where we stopped in our last class. I've talked about IP version 4 and I have broken it down. I took my time to explain to you guys what you need to know about IP version 4. Now, we did not finish that class, so I want to try to finish it today. Hopefully, the network will allow me to finish. I'm going somewhere. When you talk about IP version 4, sometimes you hear us talk about unicast addressed, broadcast address. Of course, you guys, I mean, unicast conversation, not address. Unicast communication, broadcast communication, and multicast communication. What do we mean by that? Anytime you hear that word unicast, what should come to your mind is one-to-one communication. Look at this unicast here. One-to-one communication. So when you say unicast transmission, it simply means one computer is messaging another computer. Like if I want to send a message to Toby, Roland's computer is sending a message to Toby. That is a unicast, one-to-one communication or one-to-one conversation. But when you hear multicast, multicast is one to a group of people. For instance, you people are 3 in this class now, and I don't want to talk to all of you. I just want to send message to, let's say, Toby and Benga. And Ali is there, but the message I don't want him to hear about it. So when I send a message to a group of people, that kind of message is referred to multicast communication. But when I send a message to everybody on the network, that kind of communication is called a broadcast. So these are terminologies you need to be familiar with: unicast, multicast, broadcast communication. These are very important concepts for us: unicast communication, broadcast communication, and multicast communication. Now, there are some addresses. Of course, you guys know broadcast address. We've talked about that. You know host address. We've talked about that. Host address at the same time can be referred to as a unicast address because it's an address that can be used to talk to just one person. Broadcast address is an address that can be used to reach everybody on the network. And also we have what is called a multicast address. It is an address that can be used to reach a group of people. This is used most of the time. This is used most of the time by routing protocols on the network. The router use this to talk to themselves. The switches have their own multicast address when it comes to a particular protocol called spanning tree protocol to talk to themselves. So when you talk about unicast, when you talk about multicast, when you talk about broadcast, you should understand the concept and you should know that there are some addresses that can be used or referred to as unicast address, broadcast address, multicast address. How do you identify multicast address? Any address that starts with 224 is a multicast address. Now, we don't use this on the network. We don't assign them to computers. You need to understand that. You are not going to see anybody assigning 224 to computers on the network. As in, the first octet is going to be 224. No, you're not going to see that. If you look at the range I gave you guys that day in that our class, Let's go back to that my box. This box here. Look at the range for class C, 192 to 223. What happens to 224? Anything 224 and above, it is a multicast address. We don't use that on the network, as in we don't allocate that kind of address to computers, because any address within that range is being used by some protocols for conversations on the network. So whenever you see 224, just know that it is a multicast address. Multicast address. So you guys already know unicast. You already know broadcast. Anything 224 is multicast address. I believe that is clear for you guys. So I want to go to the next part. If you have any problem or any question, just raise up your hand. If there's no question, we'll proceed from there. Or when you are feeling the anointing, give me thumbs up. You're enjoying what I'm saying. You know that, yeah, you're feeling me, you're understanding, you're flowing with me. You give me thumbs up. So thank you. I can see Toby's thumbs up. So the next one I want to talk about is types of IPv4 addresses. You see, this thing is a long journey. Thank you, Ali. I can see your thumbs up. Types of IPv4 addresses. The other day we said classes. Then later on I said categories. The other one, now I'm in another part now talking about types of IP addresses. What do you mean by that? And this part is very important to me. I'm going to really take my time in this place because I need you guys to get some stuffs here. And here, we are not talking about class A, class B, class C. We are not talking about network portion, host portion, or whatever. All of those concepts still remains. But we need to understand something here. Whenever you see an IP address, this is another set of questions you need to be able to answer, guys. I didn't get here that day. Whenever you see an IP address, you must be able to answer the question if that IP address is a public IP address or it is a private IP address. Whenever you see an IP address, you must be able to tell whether that IP address is a public IP address or a private IP address. So what's the difference between the two? For private IP address, they are not routable. They cannot browse the internet. Take note. Private IPv4 addresses, let's put it that way because we're dealing with IPv4. Private IPv4 addresses are not routable. When they say routable, they can't browse the internet. How come they cannot browse the internet? I'm going to show you. I'm going to explain that to you. So look at what they said here. As defined in RFC 1918, request for comment, public IPv4 addresses for public are globally routable. So when they say public IPv4 are globally routable, simply means you can browse the internet. Any computer that has public IP address is recognized on the internet, can be on the internet, can browse the internet, can get information on the internet, can send information on the internet. So that is why they say public IPv4 addresses are globally routable or routed between internet service providers or routers. But look at private here. Private addresses are common blocks of addresses used by most organizations to assign IPv4 addresses to internal hosts. So whenever we build our network, guys, we use private IP addresses. Why can't we use public? You cannot. Why? Somebody somewhere on the internet has been allocated the public IP address. Let me explain that again. Anybody that is on the internet, before you hook up to the internet, the service provider gives you the public IP address or IPv4 address, public IPv4 address you can use to connect to the internet. So, and there cannot be conflict on the internet. What they will give to my organization will be different from what they will give to your own organization. We must all have unique public IPv4 addresses on the internet. So what is the big deal about that? Why can't I just build my network with public IPv4 addresses? If you want to build your network with public IPv4 addresses, it's possible, but you will be in need of more public IPv4 addresses. I'm going to, just give me time, I'm going to demystify this. I probably will be able to get there. So just follow me. So now the point I'm making is this. Whenever you want to build a local area network, you are supposed to use private IP address. Whenever you are going to connect to the internet, you are going to use public IP address. So what do I mean by that? Private IP addresses are used locally or internally. Public IP addresses are used when you want to go to the internet. Let me give you an idea. Let's say I have a local area network here. This is my switch. I have a computer. I have computers connected here. Now, don't forget what we have discussed here. Computers to connect to themselves within the network, we don't need internet connection. You build a local area network, you build your LAN. These computers can share resources between themselves. They can talk to themselves. They can share resources. Forget about the internet now. So within this network that you built here right now, you are expected to use private IP address to link all those computers together, not public. Why? Because you don't have control over the public. You have control over the private. You can use the private anyhow, anytime. But the day you make up your mind that you want to go to the internet, you are going to have to connect to a router. And on this router will be public IP address. So anybody within this organization that want to go to the internet, they will get to the router. The router will convert their private IP address to public IP address, and that is how you and I can go to the internet. Within our organization, we use private IP address, but if we need to go out, we use public IP address. And who does the translation or the conversion? Our router. The router does what we call network address translation. And this topic is a chapter of its own. We're coming to that in a much more later towards the end of the training. Network address translation. So the router is going to convert your private IP address to the public IP address that has been assigned to that organization. That is how you can go to the internet. So take note, when you build your network, privately, internally, you use private IP address. But the moment you want to go to the internet, you pass through your router, and the public IP address that has been allocated to you will be on your router, and the router is going to be configured to do what is called NAT, and then the router is going to translate private IP address to public IP address, and then you can go and browse and then come back. So which address is the private and which address is the public? Guys, in class A, only block of address given for private is 10.0.0.0/8. In class A, 10.0.0.0/8. What does that mean? Anywhere you go in the world and you are within an organization, the moment you check IP address and you see 10 dots, it doesn't matter dot anything dot anything dot anything. Once you see 10 dots, you know that that is the private IP address. So therefore means all other addresses in class A are public IP addresses. E.g., 9 dots, 8 dots, 11 dots, 12 dots, 13 dots. All other IP addresses in class A, they are all public IP addresses. The only one you can use within your organization locally to build your network is 10.0.0.0/8. You cannot use the rest. Not because if you use it, it will not work. You'll be able to talk locally, but the day you have to go to the internet, you probably will have to scatter everything because you now want to go to the internet. And that address you are using, or those addresses, somebody somewhere on the internet is using those addresses. Am I communicating? Thumbs up, guys, if I'm communicating. You are flowing with me. Thumbs up. If you are not flowing, let me give me thumbs down. That means there's problem. I have question or whatever. Of course, you guys know if you have question, you raise up your hand. Okay, good. I can see thumbs up. Now, in class B, you guys know the range of addresses in class B. Okay, Gwinga, go ahead. That's your question.
So I noticed at the end of this class A private IP address, I noticed that there was that slash, and followed by 8. So what is the meaning of that slash? Of why are they giving it?
Can somebody answer that question on this platform?
Yes, 8 bits now, the first octet.
I don't get it.
Yes, it's true.
That's the subnet mask of that class A now. I have taught you that. How many times did we talk about that in our last class?
It's true, sir.
So can I move on? Anytime you see
Yes, sir.
slash,
Yes, sir.
it's
Yes, sir.
pointing
Yes,
to the
sir.
subnet mask. Okay, so in class B, guys, we have blocks of addresses given for private addresses. Blocks, not just one block. Blocks. Anytime you see 172.16 all the way to 172.31, those addresses are private IP addresses. So you could see 172.16, 172.17, 172.18, 172.19 until you get to 172.31. All those block of addresses are private IP addresses. The rest are public IP addresses in class B. Now, you and I know that class B is supposed to be /16. You see now they put this one as /12. I don't want to go into that now. Just notice that /12 and above. In fact, just leave it as /16 and above so I don't get you confused. Let me not go into that now. Now, guys, in class C, notorious 192.168. Now, I told you the other day, you're going to find out why when you check your IP address on your computer, all you are seeing most of the time is 192.168, 192.168. The only block given to us in class C as private is 192.168. Anything 191, 201, whatever, or any, as long as it is not 192.168, they are public IP addresses. This is one of the reasons why most of the time you check IP address on your computer is giving 192.168. That is the only block given for private IP address in class C. The rest are public IP addresses. Let me check my IP address and show you. I think I've done that before. I'm going to go to command line. I'm going to go to command line. Check my IP address. IP config. I don't want to do /hub. I am using Wi-Fi. You can see my Wi-Fi here. Look at what I got in display. Look at my IP address. 192.168. If you check your own, you see 192.168. Almost all my students that have ever checked their IP addresses while I'm in class, they always see 192.168. Why is it like that? That is the only private IP address given for class C, and that is what people use most of the time. 192.168. All other addresses in that range in class C, they are public IP address, meaning some people somewhere in the world are using those addresses to browse. Let's check it again. Ping www.facebook.com. Now, Facebook is giving me this IP address. So if I tell you to analyze this address for me right now, I have added to your problem. You need to tell me the class. You need to tell me the network portion. You need to tell me the host portion. You need to tell me the network address. You need to tell me the broadcast address. You need to tell me whether it is a valid IP address. And finally, you will tell me whether it is a public or private IP address. Now, if you take a look at this IP address now, this is class B. And if you look at the range of the private IP addresses given in class B, they are 172.16 all the way to 172.31. So what we have on the screen right now is a public IP address being used by Facebook. Yes, being used by Facebook. Let's check another one. Ping google.com. 142 is also class B. By the time you do the analysis, you see the network portion, you see the host portion, you see the network address, you see the broadcast address. You now tell me whether it is a public or private IP address. Let's check another one. Ping, let's say Instagram, instagram.com. I hope you guys know that all these apps, this social media that you people use, they are just websites. Ping, instagram.com. Look at Instagram's IP address. This is class what, guys? This is class A, 0 to 127.
Yes, sir.
The range of class A. And this is class A. So the only private given in class A is 10 dots, and this is not 10 dots. It can never be 10 dots because we're on the internet. It can never be 10 dots. So like what if I say ping, let me try whatsup.com. Whatsup.com. Now everybody use WhatsApp. It's a website. Look at the IP address. It's also class A. Yes, and it's a public IP address. You need to understand this, guys. So when you see an IP address, you need to have an informed decision or informed knowledge, or need to be informed. You need to be able to analyze it. You need to be familiar with the structure, format, concept of the IP address. Regardless of the class. But when we are building our network locally within the organization, we use private IP address. And I'm going to tell you why it is compulsory, or why they came up with that strategy to use private within and public out when you are going out. It's because at the early stage of networking, or let me say internet, they did not know that internet is going to explode like this. But they now saw the way the internet was exploding. People were connecting. They saw that the public IP addresses will be finished. So they now say, okay, let's find a way. How can we need to come up with a technology whereby if somebody is on the inside, the person does not need a public IP address. All he needs is private. But when he's going out, he will need a public. And one public can take care of 65,535 users. Just one public IP address. How do we get a technology like that? That was why they came up with NAT and PATs. Before, if you are in an organization, for instance, like University of Jos, where we have like 17,000 or 20,000 users, every single user that needs to go to the internet will be in need of public IP address. But then they came up with this technology in order to maximize public IP addresses. Why don't we just give these people private IP addresses within, and then allocate one IP address, public IP address to the router? And that public IP address can take care of everybody when they want to go out. That is the essence of dividing the IP addresses into two. I don't know whether we'll call it, we can't call it portion now. Let's not get ourselves confused, or category or whatever. Types. They call some private, they call some public. At the early stage, there was nothing like private and public. Everything was public. You connect, you will go to the internet. Within your network, everything will be private and public IP addresses. But when they saw the way the thing was expanding, they said, nah, we have to come up with something new. Let's pick a range of the IP address and call them private. And let's pick another range and call them public. And let me tell you guys, the only reason why you cannot browse the internet with your private is because all the routers on the internet have been configured not to allow your traffic to go to the internet. That's the only reason why your so-called private IP addresses cannot go to the internet. If not, IP addresses, they will have gone out. Did that make sense to you guys? If I do, thumbs up. Yeah, good. So now this page now, this slide now will make sense to you guys if I read again. Public and private IPv4 addresses. So private is used to build your network locally. Public is used to go out. So who gives you that address to go out? Who gives you the IP address? This is technology I talked about earlier. You are going to learn how to set up this in the last part of this training, how to set up NAT. Okay, I want to show you something. These are the people that manage the public IP addresses for different continents. This one here, they are the one that manage for Africa, Afrinic. So what do I mean by that? when they are sharing public IP addresses for different continents, all the public IP addresses that we ever need in Africa will be given to these people here. It will be given to them. Then they will now come and say, okay, these are the public IP addresses for Nigeria. These are the public IP addresses for Kenya. These are the public IP addresses for this. These are the public IP addresses for that. So all over the continent, they will distribute the public IP addresses to different countries. That is why if there is an attack, they know the people they give the block of IP address to, they know the country. So they can tell this public IP address was given to Nigeria. This IP address, public IP address, this attack is coming with this public IP address. That means this attack is coming from Nigeria. So when that thing, if that thing is given, and of course the way it goes is this way. We have what they call regional service provider. Then you now have so is it regional service provider, then local service provider. So they will give bulk of these IP addresses to the regional service provider. Then the regional service provider will subnet those addresses and give to the local service provider. Then the local service provider will subnet those addresses and begin to share with for their customers. And these are all public IP addresses. That is one of the reasons why you need to know subnetting like you know yourself. And that is going to come up in our next class. You need to know subnetting because it is a way to manage IP addresses, either public or private, especially public IP addresses. So there are other body. We have LACNIC. Can't remember the one they manage. We have HARIN, we have RIP, we have APNIC. Maybe in many time I'm teaching this, I have to check this one out. I know one is in charge of America, and one is in charge of Asia, one is in charge of I can't remember. These are just the body that manage all these public IP addresses for different continents in the world. That is why you can never have what we call IP conflicts, meaning two different two different customers having the same public IP address is not going to ever happen because there will be conflict. If they have allocated something to me, an IP address to me, it won't be allocated to you because it will be documented that this address has been given to so organization. This public IP address has been given to so organization. And another thing you need to know, public IP address is not free. When we say it's not free, when you pay for internet connection, part of what you pay for is the public IP address. I'm not talking of when you use GSM router, please. I'm talking of people that get internet connection directly from the service provider. Like in Nigeria, you get from MTN, you get from Airtel. Those people, there is no way they will give internet connection and not give you public IP addresses. So you pay for it, it's not free. The private IP addresses are free. It's within your jurisdiction. If you like, you can go and pick class B, private IP address. If you like, you can go and pick class A. Nothing spoiled. You're good to go. So you need to understand that. Okay, I'm going somewhere. Special use IPV4 address. Toby asked a question in our next class. He said, why am I not using 127? I say, smart question. Because when I gave you that range, if you take a look at that table again, we have 1 to 6. Some materials we put 0 to 6 for you. 1 to 6 is what I put. Look at my home. Look at the range here. 1 to 126 rather. I did 1 to 126 for class A. And now for class B, I say 128 to 191. And Toby spotted it with his eagle eye. He spotted it that 127 was missing. Not many people can see that, not everybody. So now this is the reason why we miss 127. I miss 127 out of 8. Because you don't allocate 127 to computer. 127 address, anything 127 is called a loopback address. Look at the range here. 127 0.0.0.1 all the way to 127.255.255.254. Any of these addresses can be used as a loopback address. What is a loopback address? This is one we use most of the time. 127.0.0.1. We use to text TCP/IP if the TCP/IP of that system is operational. So I can go to my computer right now. If I'm troubleshooting and I'm suspecting that is there a problem with my network card or with the software of my network card or the TCP/IP stack is not activated, I will just say ping 127.0.0.1. What am I trying to do? I want to test the TCP/IP stack. I want to see, is there a problem with my TCP/IP stack? And that's one of the reasons why you need to know about OSI model and TCP/IP. You know that what we are doing, TCP/IP must be in place. And that is integrated into the operating system. If I hit enter right now, I must see a reply. So when you get a reply from 127.0.0.1, that suggests to you that your TCP/IP stack is intact. So you don't have a problem with TCP/IP stack. That is the use of this particular IP address. And this is one we use most of the time. But you can decide to use .2, .3, .4, .5. It doesn't matter as long as it's within the range of 1 to 7. That is what we use 1 to 7 for. If it's clear, give me a thumbs up. Toby and others. I'm not seeing Benga's thumbs up. It is on hiding today. I can see Benga's. I can see Ali's own, but I'm not seeing Benga's own today.
I'm putting this in, so I don't know why I'm like using it.
No problem. If I don't see it, and that means I want to assume it is you are cleared. But if you are not cleared, you just raise up your hand and then let me answer a question.
No problem, sir.
All right. So guys, let's move on. Another address you need to be familiar with. You're not going to ever see us allocate an IP address to computer and use 169. Never. So anytime you see 169.254.anything all the way to this address here, 169.254.255.255, anytime you say 169.254, you should know that there is fire on the mountain. There is fire on the mountain. There's a problem somewhere. What kind of problem? This address is what it's called a IPV4 address, automatic private IP addressing. Automatic private IP addressing. It is a self-assigned address. So why will my computer give itself 169.254? Microsoft or Windows, they've just put this for novice, meaning what? If to say this is Aliyu, you want to talk to Benga and they don't know anything about network, they can just run their cable, connect their cable, and they'll be able to share resources without allocating IP address. So where will the computer get IP address from? Don't forget that computers come with DHCP enable, meaning obtain IP address automatically. I'm going to go and show you again now. We've done that before. So when you leave your computer to obtain IP address automatically, what you are simply telling the computer is go and look for a DHCP server out there, a server that dishes out IP addresses, a server that allocates IP address, and get one for yourself. So when you tell the computer to do that, and the computer does not find the DHCP server, it will just give itself 169.254.anything. And that is not going to be a problem if you want to talk to another person locally, you want to share resources locally, but it's going to be a serious problem if you want to go to the internet. Why? That address is not known on your local area network. That address is not allowed or permitted to go to the internet. So you got to solve the problem. Why is the system not getting an IP address? So most of the time, maybe your network, you're supposed to get 192.168 or something, and you see this, it probably means your DHCP server is down. Please take note. This is interview question. They've asked one of my students this twice in different interviews. I think 2 different students actually. So take note of this. Whenever you see 169.254, DHCP server is down, or is available, the cable that connected it to the network is down, or the switch that is connected to is down, or your computer here is the one that is having a problem not seeing the DHCP server, and you now need to find out why that system is not seeing the DHCP server. So I am trying to tell you that this address in the time past was okay if you want to just connect themselves and share resources, but we don't want people to do that. We want the system to locate a DHCP server. If you see this address on your system, there's fire on the mountain. Let me show you something. Don't ever forget how to go to where the system used to, we used to tell the system to obtain IP address automatically. There are different ways, but I prefer the control panel. So I can go to my control panel now. Then go to networks and internet. Then go to network and sharing center. Then come to change adapter setting. Then right click like my Wi-Fi now. I'm using Wi-Fi. And then come to properties. And then look at it. You select, look at my TCP/IP version 4 is selected. I select this and then go to properties. Now, can you see the first option here? Obtain an IP address automatically. That means I have activated this system to go and look for a DHCP server. In this case right now, it's my router that is a DHCP server. It's the one dishing out IP addresses to my computer, the router I'm connected to. And I'm also telling this computer, obtain DNS address automatically. I don't have any business with DNS. Everything you need, just talk to the router. The router will give it to you. But if I off my router now and I still leave this thing like this and I'm trying to connect to maybe another person's computer, then my computer will just give itself 169. So sometimes you want to find out, is this thing even activated? Obtain IP address automatically. You can go to your command prompt and see something. Let me show you something here from our command prompt. Let me show you something here. From command prompt, guys. Watch my. I wanted to clear. I forgot the command to clear. Oh, this is CLS. Yeah, CLS. Watch my command prompt, guys. IP config /all. We've been using this command before. I've never pointed to this. Look at this place here. DHCP enabled. Yes. On my Wi-Fi. And that is what you are seeing here. What is that thing again? On my Wi-Fi. Look at it here. Obtain IP address automatically. That is the DHCP enabled. It simply means I enable my computer as a DHCP client. Go out there and look for a DHCP server and get your IP address. And what did this particular computer get from my computer? I mean, from my router. Look at what it got. It got, this is the address it got, 192.168.1.15. How did he get it? Through DHCP. It's my router that is DHCP. Look at the IP address of the DHCP server, which is my router. My router is the DHCP server. It's the default gateway. And it's also my DNS server. It's everything to my computer here right now. So you need to understand now. So by default, your system comes with obtain an IP address automatically. When I say by default, the moment you install an operating system, this one is activated. You only move this thing to static if you want to, maybe you want to do peer-to-peer, that is connection from one computer to another on your own, and you know what you are doing. You assign IP addresses. So this is key. So anytime you see 169 and you know you have a DHCP server and you guys want to go to the internet, there is fire on the mountain. And you need to solve the problem. That computer will never be able to browse, or those computers will never be able to browse. And most of the time, it is when your DHCP server is down that this happens. But once the DHCP server is up and running, you are not going to see 169.254. Please take note of that. This address is called a people address or self-assigned address by your Windows, by your computer. It is only meant for novice to link two or more two systems together. But once you connect to the network, you should get a different IP address, not from this range. It shouldn't be from this range. Thumbs up if you are good. I have another meeting in the next 5 minutes. I'll enter that meeting late. It's one management meeting. I want to have a place I want to get to. If not because of the network, we should have been rounding up by now. Okay, thank you, Ali. I saw your thumbs up. Toby, I didn't see yours.
I've sent more than 4 thumbs
I
up
can see
now.
Benga. Benga has sent more than 3 or 4 times.
I know see Benga's own, no, it's hiding.
I saw Benga and Toby's own.
Before, now Ali's own, no, they sit. Today is Benga's turn.
Ali, you don't go do this thing for me for Port Harcourt.
All right, guys, let's quickly finish this. So, we've talked about class A, and you guys know the range of class A. We've talked about class B. We've talked about class C. I just mentioned multicast today. Multicast is in the range of class D, which is from 224 to 239. 224 to 239. So, class D addresses that computer use or some application use, operating protocol use, they're always from this 224 to 239. That means you can have 224, you can have 225, you can have 225, as long as it's within that range. Then we have the last one here, which is class E. Class E is used for research purposes. So the ones we use on the networks are just within the range of A to C. Meaning when we build our network, when we allocate IP addresses to the network, the addresses we use are just between the range of A to C. We don't have any business with D, we don't have any business with E. That's the way it is. And you need to understand that. And I think I've told you guys when to use C, when to use B, when to use A. Look at C, maximum address you can give is 254. B, maximum address is give is 64,535. A, the maximum address is 16,777,214 IP addresses. For big networks like university or what we call campus network, we go for class A, or sometimes for class B. But we don't just build flat network, we subnet them, break them in pieces until they now enter class B, or A to enter B, B to enter A. That is how we break IP addresses into pieces. And that is what we're going to do in our next class. It's a full-blown class. Subnetting, network segmentation and subnetting, I'll tie them together. So I would like to draw the curtain here, guys, today. I have another meeting.